Okay, so far so good today. Lesson 3, we were able to record no issues, no announcements. So let's try lesson 4 too. Why not? See, look, there's lesson 3. We have it recorded. Beautiful. So for lesson 4, my goals for you is that you remember how to read a graph. You remember what a linear relation is. You remember what graphs of linear relations look like. You remember how to interpolate. Remember, we're looking in the data when we interpolate. And then hopefully by the end of this lesson, you will now understand what it means to extrapolate. Okay, so let's get started. So the first question says, I want you to interpolate by finding the approximate values on the graph. So using this graph, and I know that the one that printed for you wasn't the best, but hopefully now that you see it on a screen a little bit larger, you can extrapolate. So I'm looking for the value of y when x is -8, value of x when y is -7. So you're going to interpolate, you're going to try and figure out using this data, using this graph, where those different points are. We are going to check that first thing tomorrow. So moving into our new content, extrapolating. So interpolating was looking inside the data to find another piece of data. So to extrapolate is we're going to estimate a value that is beyond our data. Okay, it's beyond our data that's given. It's beyond our data set. Okay, so we're looking for extra data. It's outside of our data set. We're looking for more values. So extra is more. Okay, so it's beyond. We're looking for more data, something that's not already in our data set. So looking at our first example. So our first example says, Quagmire is flying to the west coast for a vacation in British Columbia. His flight path is shown by the red arrow on the map. So personally, if I was going to the west coast of BC, I would go to southern British Columbia, where it is nice and warm. I'm sure northern British Columbia is very beautiful, but I can't imagine that it's quite as warm as Vancouver or Victoria. Just a personal preference. Anyways, so if he's continuing on his map, so if you notice, his flight path is shown. We've started here. Now this, we don't know if that's where his flight started, but that's where the tracking of his flight path started. And then the arrow shows the direction that he's flying. So he's flying definitely to northern British Columbia. And so it says, if he continues on this course, where might he end up? So the only point we can really see if we extended this data line would be maybe Fort Nelson. Okay, but we would be extrapolating. We're making a guess. We don't know. We are assuming that his flight path, is staying constant, that he's moving in a linear line, like in a straight line. He's doing a linear relation. His path isn't changing. And so when we look at B, is it possible to determine where he is flying from? So again, we want to extrapolate, but going backwards. So if we extrapolate it backwards, okay, so maybe he's flying from Regina, but we don't know. Did he start flying in Canada? Maybe he started flying in the US, right? Or maybe beyond. Like, we don't know where he started from. So is it possible? I would say no. We don't know what country he started in. We don't know if his flight, maybe he started in Calgary and they flew like this. Maybe he started from Edmonton. Maybe he started from Saskatoon. Maybe he flew from Kamloops. I don't know. Right? There's many, many, many possibilities. We don't know which one it is for sure. So no, we can't, for many different reasons that we've listed. I sure hope you wrote one of them down. Okay. So again, on yours, I can't say that this printed out the clearest, so I don't know if you can see the values super well. But here we have a graph talking about the value of a computer decreasing over time. Okay, so we've got the value in dollars, and we've got time. Let's say that it's measured in years. So the graph shows the value of a computer after it was bought. So the starting value is $1,000, and the value is decreasing at a constant rate. So this is a linear relation. So our first question says, after what approximate, so we're estimating, approximate period of time does the computer have no value? So what we're saying is we need the value to get down to 0. So we need to reach that bottom line. So we need to extrapolate. So we're going to continue the line. So just using your ruler. It's always, if you just start at the end, it's hard to keep the same angle of the line. So I find, or the same slope of the line. So I find if you start further back, it's a lot easier to get a line that actually matches up. So if I trace over the line as best as I can, it shows me that after what approximate time does the computer have no value? Well, this is where it has no value, right? Because if we trace back, this is a value of 0. So that's after approximately 5 years. And that sounds about right. That sounds like a reasonable answer. After about 5 years, if you go to turn around and sell your computer, you're probably not going to get much for it. If you get 50 bucks, that's probably a good deal. Okay, so then second question says, what was the computer was the computer worth approximately $200? So here's our value of $200. So I'm going to trace out to our line that we've extrapolated, and $200, that's at approximately 4 years. So it looks like the computer's losing a value of $200 every year. So then the next question says, well, is it appropriate to join the points with a straight line? And so what I want you thinking about, and I know we've talked about this before, is the data discrete data or is the data continuous? So what that means is, does it make sense to have values? So can we have money between 1,000 and 800? Well, yes. Can we have values between $999 and $1,000? Yes. We have change and pennies and all that stuff. So value or money is a continuous property. So then we need to think about time. Well, does time exist between one year to the next? Yes, there are hours, and then we could go down to minutes and seconds and milliseconds and et cetera, et cetera. So both time and value are continuous properties. So both. So since they are both continuous properties, we can connect the dots. Because remember, when we connect the dots, it's saying that this value could exist. Somewhere in between those points could exist. Now, if instead of time along the bottom, if this said number of computers, would it make sense to have 2.27 of a computer? No, that doesn't make sense. So then they would not be continuous data, so it would not make sense to connect the dots. But because we are talking about time and money, it does make sense to connect the dots. So I really want you thinking about that and being critical of what you're looking at. Looking at our next graph. This graph represents the relationship between the cost of renting a power washer and rental time. So we need to think, well, there's no labels on this graph. We need time and we need cost. So we need to think which is dependent and which is independent. Well, time is the ultimate independent variable. Time happens no matter what. If you can control time or time travel, you should probably share that with someone, maybe Dragon's Den or something, and make your bajillions of dollars. And then travel back in time and tell me about it ahead of time so I invest in you and then I make bajillions of dollars. So until we learn how to time travel, time is an independent variable. And so let's measure this in hours. And then the dependent variable will be cost. And that's going to be measured in dollars. So the cost is going to depend on the amount of time that you rent the washer for. So first one says, how much does it cost to rent a power washer for 4 days? So I'm going to change our time from hours to days, because otherwise we're really going to have to extrapolate and it's not going to make much sense. So let's go to days. Okay, so 4 days. So we're going to follow up our line. You can use a ruler or something to help us. And so at 4 days, it's going to be somewhere between 250 and 300. Okay, so if we say it's going to be approximately maybe 275. That was really bad. Approximately $275 or $280 or somewhere in there, okay? We're interpolating, so it's not going to be exact. We're making a good estimate. So then it says, how long could we rent the power washer if we had $420? Okay, so, oops. So $420 is somewhere up there. So I'm going to extend this line just so we can extrapolate a little bit better. And so $420 is about here if we extrapolate out. That takes us to about 6 days. So approximately 6 days, maybe a little bit less, but pretty close to 6 days for $420. Okay, so that is the end of lesson 4. Please make sure that you do those first sets of questions for me to review your interpolating, as we will check those first thing tomorrow.